Okay, I'm going to call on somebody. Very quickly. All right, ready? Let's go with Pauline. Pauline, real quick question. Where was this survey taking place? Where did this peppered moth experiment occur? Manchester, England. Good. And last, let's go with Alan. How many years did this whole phenomenon take place? Yeah. Okay, good. So about what, 45 years, right? Good. Now, one more specific. How many span of years did they collect data that we're going to analyze? Yes?
Oh, wait.
Close. How many years are we just going to look at? We collect the data, yeah? 10 years. So if you read right here, if you read the table, you said we are going to look at 10 consecutive years. So we're going to be collecting the data from 10 consecutive years. So that's this. Now what this shows us is the number of light moths captured and the number of dark moths captured. Now one of the things that I actually was pointed out by a student a couple periods ago was that they thought in their head that what it meant that a moth was captured, they thought it means the bird got it and ate it. No. This means I'm a scientist. I want to see what's going on with populations of light and dark moths in this forest. So I set up these traps that if a moth flies into it, it gets captured. And so the idea is if I randomly set up like 20 to 30 traps, and I go out every couple of days or weeks and then I collect my data, the more moths of a certain type there are, the more likely I am to capture them. So what this means is in year one of the study, does that mean in the entire forest there were 556 light moths and 64 dark moths? No, that means that's how many I captured. So if I captured way more light moths, that means that there must be a larger proportion of white moths in the overall population. Okay, so looking at that data table, spend 10 seconds, talk to your neighbor, and determine what is the independent variable and what is the dependent variable for my graph that I'm about to do. And remember, the independent variable always goes on the x-axis. The dependent variable, for this case, is going to go on the y-axis. And here's the clue. A dependent variable is typically always what we are measuring and collecting data on. The dependent variable depends on the independent variable, and we don't know until we measure that. And then we figure out what our dependent variable is. The independent variable is known. Okay? Got it? So talk to your neighbor. 10 seconds looking at this data table, right? What is the independent variable? What is the dependent variable? What's going to go on the x-axis of my graph? What's going to go on the y-axis? I have this whole thing already screencast and attached to your assignment with the YouTube video showing you how to do it. You didn't find it? Did you find it? It's on. No, that's a good instinct. All right, I'm going to call on somebody. Ready? Who wants to just raise their hand? Let's do that. Who wants to tell me what the independent... Actually, let's do this.
I'll call on someone. Kaylin! Kaylin, which is the one that we can... Which is the one that's going to give us information about our study that we're really looking at? This is the one that we really want, that's going to tell us something about the world. The number of moths. Is it in our power how many moths there are? Is it up to us how many moths show up?
No.
So which variable would that be, the one that's out of our power? Independent or dependent? If you're able to do something by yourself, are you independent or dependent? Independent. So this one you're not able to do by yourself, so you must be dependent. So which one's a dependent variable, Caitlin? one that's out of our control.
So then what would be independent variable then? in
I'm
this case?
yeah. She hasn't answered dependent yet.
Oh.
What's the dependent variable? I think on this one it's easier to figure out what the dependent variable is.
The number of months.
The number of moths that show up, right? So what's our other? Can you go back to that Mr. Cat table?
You said go your whole class.
Which table?
You want to see the table?
Yes.
So what's left besides the moths? What else can we look at? So which variable is that? Can we decide which years to look at? Is that in our power? So which one's the independent variable? The independent variable. It's in our power. Huh? Brilliant. I knew you'd get it. Did I bring up all your memories from last year?
Yes, clueless.
All right. So this is going to be time, and we usually put the units in the parentheses. What's the units, class? Yeah. All right. So here's what we're going to do. Now, 99.9% of my students don't know how to do this. Even the A students. They look at a graph and they're like, "Oh, crap. How am I going to scale this?" Right? Let me teach you a real quick hint. The first thing we're going to do is thank you, Mr. Strauss. The first thing we're going to do is we're going to deal with the independent variable first, okay? So we're going to do that. Now, if I look, I know I need to put this on the x-axis, right? And so first thing I need to know is, well, how many lines are there? So I'd have to count. And if I were to count all these lines over here, I end up having 30 lines. If I were to count the lines over here, okay, on the top, I end up having actually 28 lines. So it's good information to have. Well, I want to put the independent variable, right? The independent variable goes down here. This is the independent variable. Okay, so I'm going to deal with 30. So what's the largest number that I need to account for?
3. Oh, snap. 10, but you're going to space it 3.
10. So what's going to happen is I take the largest data point and I divide it by the number of lines, right? So this is the largest data point, and the bottom, the denominator, is the number of lines in my graph. Now, everybody knows, well, Mr. Bear, I don't have to learn this because Excel does this for me. Well, it's good to, if you have to do a graph on a graph paper and understand how the scale works, it's good to know how to do it on your own. What's 10 divided by 30? You're going to get what, class? It's going to be 10 divided by 30 is 0.33, right? 3333333. Now, I looked out. That tells me what each line is worth. Now, here's where you might come into a secondary problem. So, all right, Mr. Beer, now that I know that each line is worth 0.3, what does that mean? Am I going to label it like this? 0.33, 0.66, 1, 1.3? No. Does that make sense? What should I do? How should I label this? If every line is worth a third, or 0.33, then how should I number these lines? Should I keep on doing this? Should I keep on doing what I'm doing?
No.
Should I put this line is 0.33, this line is 0.66, this line is 1, this is 1.33, 1.66, 2. What is it? Count. Samantha says count by every 3. You are right. You're right. So every 3 I'm going to go 1,
1, 2,
2.
3, 4, 5. You get the bed.
Everybody see that? With the very first one being 0. Now, how do I label this? What is the label going to be? Not years. Time, and then I put the units in years. Right? Okay, I do the exact same thing for the dependent variables. Now I'm going to have 2 lines here. I'm going to have actually 2 sets of dependent variables. I'm going to actually draw 2 lines on one graph. I'm going to do this one, right? I'm going to draw like a red line. And this one I'll do like a blue line. Okay? What's the largest data point that I have to take that I have to account for, class?
38.
638. You are right. So if I do 638, right, the largest data point, divided by 28, which is the number of lines, each line is worth 22.7. Uh-oh. We got a problem here. Am I going to go like this? 22.7, and then this next one is going to be like, 45.4. Am I going to do that? How can I avoid this horrible math? What should I do with that number? 22.7. Round it to what? What number would be easy to count line by line? 25. Do I want to go down or do I want to go up? Always up. I want to round those lines up. I want to make sure that I have enough to cover my highest data point. So I never want to round down. So I said every line is worth 25. So am I going to write 25, 50, 75, 100? What's the problem with what I'm doing right now? It's taking too long and it's too cramped together. So every 4 lines is, everybody's doing this, right? Well, if each line is worth 25. So everybody should be setting up their scale. I can't tell you how many times I see people do a graph and everything's all crammed into the corner. Because they're not setting up their scale right. They're not setting up their lines of being the proper, appropriate value. I think I'm off a little bit here. Yeah.
That was pretty good. What do you think?
I never said it wasn't good. I just said
Uh-oh. Yeah, it should end up perfectly. And this should be the number of what? Alright, so now I'm going to start you off. I'm going to use different colors. You guys have colored pencils over there. I'm going to start with doing the first line. Can you guys help me out and give me the data point so I don't have to go back and forth? The first data point is going to be 556?
Yep.
So year 1, I'm going to start with year 1, right? 500 starts right here, then it's 525, then 550, so 556 is right around here. What's your 2 data point, guys?
537.
So 525, and in between 525 and 550 is going to be 537. And then for year 3, it's what?
484.
484, so it's going to be somewhere right here. So you can start to see my line forming here, right? Now you guys would continue on and finish it all the way through year 10. Now I'm going to need a key. Right, I'm going to need a key right here to tell me that I'm using red for the light colored moths. Right? You guys can do like a dotted line and a solid line if you don't want to grab different colors. But you still need, right, to have some sort of key so that I can know what each line represents. Now I chose to use red and blue. So what's the first data point, right? Now the first data point here is 64 for year 1. Now this is the dark moths, right? So 64 is going to be right around here. Year 2 is going to be what? 112? And then 198. So then the dark moths start to go up like this. So I'm missing, and then I put my key here. What am I missing for my graph, guys?
Title.
Thank you. I need a title. A title must include 2 things in its name. What are the 2 things that must be included in the title? The what? Both variables. It's not a title of a movie, it's not a title of a book, it's not a title of a song, it's a title of a graph. And the title must explain exactly what these lines are representing. The reason why I'm even making this graph is because when I look at this data table, all I see is a bunch of numbers. I don't see how these numbers relate to each other. I don't see the story that these numbers are telling me. I can't analyze. I can't see trends. I can't see correlations. I can't see similarities. I can't see differences. But when I put them in a graph, then the graph should stand on its own. I should be able to look at the graph and have no need for the data table. And so the title should include everything about it. So, who wants to give it a shot and give me a good title for this that includes both dependent and independent variables? Who wants to raise their hand? Give me a good title to put on here. It must include both. Yes. Good. The number of moths captured. That's the dependent variable over 10 years. Good. Let's get a little bit more detail. Let's take that really good title and make it better.
The number of light and dark moths.
The number of light and dark moths over the course of 10 years. That's good. Who can make it a little bit better? Yes.
Number of light and dark peppered moths.
Over 10 years. Throw in the peppered moths. Yes, that is good. That is more accurate. It's telling us what type of moths. Yes, that's good. Now we're getting less specific. I want to know exactly 10 years. Whatever.
I said decades.
In Manchester, England. If I read that title, I know exactly what this graph is telling me. It's telling me the number of light moths and dark moths captured in Manchester, England over the course of 10 years.
That's a very
But that, this is nonsense. What is? You know what it is? A really good title for that graph.
It is. We repeat it. Number of light
You know, I
and
mean,
dark moths.
that's just the best one. You can just say the number of light and dark captured. Because you should be able to hand this graph to somebody who knows nothing about the background, nothing, and they should be able to look at your graph and extrapolate all the information that that graph is trying to convey. They should see, oh, look, this is years, because it says years. This is 600 what? 700 what? Oh, number of moths. Number of moths what? Oh, captured. Okay, number of moths captured. What's the blue line? Oh, light moths. Okay, that's dark moths. Okay, where is this? Oh, Manchester, England. I got it. Everything's there. The labels show you everything. That's a good title if it's labeled. If you're, let's say you didn't put this, guys. Let's say you did not put this. What would be the problem with leaving that out?
They would think actual.
They don't know what it is.
Could be in months.
It could be 5 what?
5 minutes.
Could be 5 minutes, could be 5 days, could be 5 months,
5 seconds.
could be 5 seconds, right? The years. Got it? So you guys got about it. I think it'll take you about, no, I'm going to give you guys about 20 minutes. I'm going to give you 25 minutes. When you're done with the analysis questions, this is going to go in your work section of your binder check. Okay? I'm going to leave that up there. Is that okay if I leave that up there?
No.
Give you guys an idea of how to finish it. You guys use the data table to plug in the rest of the remaining things. The question that you don't need to answer is the last question that talks about what type of sudden evolutionary trend is this. The answer to that is punctuated equilibrium. We haven't talked about it yet in this class, so I won't hold you responsible for that question.